In this lesson, we're going to learn how to create a web server on NodeMCU ESP8266 so that we can able to control the LED connected to ESP8266 through our web browser.
This video is sponsored by Altium Designer. Altium is the best PCB design software. If you're working on a hobby project or a professional project to prototype your idea on a real PCB, I'm sure using Altium for PCB design will be the best investment of time. Claim your free trial today with the link in the video description, and I'm sure you will be amazed with its great features and capabilities.
The code will begin with this include statement. Now, if you want to download this code, then I have given the link in the video description, the GitHub URL, which you can click and download the code. Now, the code starts with the first line, that is an include statement. It's an ESP8266 Wi-Fi.h header file. So this basically allow our NodeMCU ESP to connect to the network, because in a station mode the NodeMCU means ESP8266 needs an internet, and it will take an internet from our nearby access point. So in my case, I have an internet, my laptop is connected. Look at this in lower right corner. My laptop is connected to this access point binary updates, and I want my NodeMCU also to connect to the binary updates network. That's my internet router. So it will get an internet network, and then it will create its own web server that will be accessible into that local network. So every device in this network will able to access the web server running on NodeMCU. So basically this ESP8266 Wi-Fi.h will let our NodeMCU to connect to internet, and then the another header file ESP8266 Webserver.h allow our NodeMCU to handle the HTTP request, because the server, the web server that we are creating on the NodeMCU ESP will be an HTTP server. And then we have to put the SSID and password, because as I said, NodeMCU has to connect to the internet, so it needs this Wi-Fi credentials so that it will connect to the internet network. Now we create the object. So you see ESP8266 web server, this is a class coming from the same ESP8266 Webserver.h header file. So we create this server object, which takes basically a constructor, that's the port 80, because as I said, you know, this web server is an HTTP web server, so it understands the HTTP protocol, and the HTTP server has a standard port number 80. That's why we pass this port number 80. Now, the significance of putting the HTTP port 80 here in the code is because when you access this web page which is running, the web server which is running on the NodeMCU, look at this here in the browser, you don't need to mention the port number. You just have to put the IP address of your NodeMCU, and then it will present, the web server will present this nice beautiful web page onto the client. Now this browser is a client. On the right side you can see, that's why I have opened up already for you just to explain this concept. And this code, which is what I'm explaining right now, will be running inside the NodeMCU, which will create its a web server. Then we create a boolean variable LED status, because we want to control the LED, so we will define it as a low in the beginning. And then in a setup function we initialize serial monitor with 9600 baud rate, then we give decent amount of delay. Since the LED will connect it to D4 pin, that's a built-in LED, blue color LED that we have on NodeMCU, we want to configure into the output mode because LED is output device. Then we throw some strings onto the serial monitor connecting to this SSID. In my case it's a binary updates, and then Wi-Fi.begin. So it's basically the Wi-Fi on the NodeMCU ESP8266 will try to connect to this SSID with this password, and this is how our NodeMCU with this line of code will connect to the internet network. And then it check in this while loop whether if the NodeMCU connects to network or not. Look at this Wi-Fi status. If it's not equal to WL, that's the wireless connected, then it take 1 second of delay, and it will keep printing ... until it connects to the network. And once it found the right SSID and password, then this few lines of code will execute, and it says Wi-Fi is connected because it got the SSID and password correct, and then got the IP address, and this local IP address will be assigned to the NodeMCU, and that will be printed onto the serial monitor. Because this IP address will be assigned to the NodeMCU by our internet router, which is a source of internet in a station mode. In a web server in a station mode, the NodeMCU gets internet connectivity from the router, and router assigns the IP address. And look at this IP address is basically assigned to the NodeMCU by our internet router. That's the source of internet. So that's basically, we need this IP address so that we can put it into the browser. That's why we print this Wi-Fi local IP address on serial monitor so that we can copy and paste it in a browser. So the way I have pasted here in our Google Chrome, you can able to take your mobile phone and put the IP address of your NodeMCU into the browser, and then you can able to see you have the same web page will be shown up there, because that web server will be accessible in entire binary updates network, which is where this NodeMCU is connected to. Now going ahead with the code, you see we have a server.on method. So basically the way this web server, the way this browser, this web page basically controls the NodeMCU is by sending, or maybe sending a request, because if you know, HTTP is a request and response protocol, so it works in request and response. So what happens basically is the client, that means a browser, when you press the button, right, when you press the button, when you do something here, when you press this button, then the request will be sent to the server. Server is what? In this case it's our NodeMCU. So when you press the button, then something happens, right? And let's say if I just put this is basically the IP address of the NodeMCU. Say when I hit enter, okay, I will be presented with this web page. It's a dynamic web page, but this is what it means. So server, so this client will send the request when the URL will get called. That means the server will get called by the client, that means by our browser, and the first URL will be a root URL. Look at this, server.on. So when the server is running, then when somebody requests the root URL, that means the home page, this is what we call as a root URL, then this handle on connect method will get called, right? And that's why we can able to see this web page when somebody put this URL and hit enter onto the browser. Then when somebody call this URL, this routes /led on, then this function will get triggered. When somebody call this URL, so look at this, when I press this LED on button, let's just concentrate on this first routes and the first function call. So when I press this on button, look at the URL when it changed. So when I press the on button, the server's IP address /led on will be sent it to the server, from client to the server, and this function get invoked because this is coming from the client. Look at this. That's why here the client is sending the /led on route or URL that it called. Now when I press this button again, then you see the URL change and it says LED ops. So this URL will get request to the server, and this will get invoked. So this route will get handled by the server, and then this handle LED off function will get invoked. I hope you get the point. Like when we press this buttons here, LED on and off, this functions will get invoked. Now this server.on, so server is the object created with web server class on ESP8266, and this on methods takes two parameters. So first is the URL which we want to hit, and which get called from the client, and then which function to get trigger, which function to get call, invoke, right? So that's basically what it is. Like here in this case, this URL will get called and this function will get invoked. Here this one, here is this one, and when look at this, this is when the web page connect to the NodeMCU web server. So this default web page you will get, right? This web page you get. Now when somebody press this button, then this second on button handle LED on function get invoked, right? And then this one. But what if somebody put the URL of the web server, but the web server doesn't exist? So then this handle not found function will get invoked, which will then generate an HTTP response code, let's say 404 or something that page couldn't find or something like that. So I hope you get a clarity on this, because this four statements are very important. There are four activities. One is the home page. This is what to happen when you press the on button. This is what to happen when you press this button again, so that will turn off the LED. And when nothing really exists, when the web server doesn't exist onto the NodeMCU, then this has to show up. Otherwise, user doesn't know, the client doesn't know whether the server exists or not. Correct? So that's basically a problem. Let's say you go to visit a certain website. Let's say you go tomorrow and visit www.binaryupdates.com, and if that website doesn't exist, then you will say this page cannot found, or server doesn't exist, or something like that. So you need to have some information that this website doesn't exist, this web server doesn't exist. Now don't take this example that I've given similarly, because here we are talking about a web server, a lightweight web server running on to the microcontroller, which is a little bit different than hosting a website. But the idea, the concept of a server and the web server remains same throughout everywhere. Now look at this server.begin. So that's basically starts basically the server, web server on the NodeMCU by calling this function, and then finally we get the message on serial monitor that the HTTP server is already started. And then in a loop function we say server.handle client. So when this function in the continuous loop function will get called, then our server, that means our NodeMCU, keep listening for this 4 events, right? I mean the 4 requests coming from the client, and client is basically our web browser, right? So whenever some activity happens on the web page, the request will come to the server, and server will handle this request coming from the browser by calling this handle client function, right? And then we check the LED status, getting the high and low value, basically a logic high and logic low onto D4 pin. I hope you know the LED blinking example code, very basic NodeMCU code. If you are not sure about this, please check out my other videos. I have given a link of a playlist into the video description, so that will help you clear up your idea about the basics. And then we have a couple of functions like handle on connect function, which we talk about here. So this function, we have to write a code for what to do when this function get handled, right? And that's exactly what it's written here. So handle on connect function by default will have the LED status low. So when it connects, let's say when I put this URL here, when I call, by default the LED status will be low. That means the LED is off, right? So LED is off. Look at this, that's why it says LED is off. And then the server.send, so this basically, this line basically dynamically generates the response, this one, to be shown on the browser, and it takes basically 3 parameters. So first is the HTTP status code 200. That means the client, when send the request to the server, to the NodeMCU, and if the communication happens successfully, then 200 OK will get invoked. And then what type of data that we want to send, so it's the text HTML, and then update web page is basically a function that generates a dynamic web page, and what data that we want to send from server to the client, and that's the LED status, that's basically on and off. So this handle on method will send the LED status to be high, that turn on the LED. Handle off method will send the LED status to low, that basically turn off the LED. And handle not found basically sends the response 404 error code. That means the web server doesn't exist when handle not found method will get trigger invoked, and not found will be shown on the client. And then you can see here we have a function that is update web page, that basically generates a dynamic web page, as I said, which again takes the parameter as the LED status. Means basically all the data that we are sending from server to the client, means web server on the NodeMCU to the client to the web page, is basically this LED status, means either it's a high or low. Okay, so it's basically to turn on and off LED. So that's exactly the status that we want to monitor, or maybe send it back and forth, because we also want to dynamically generate the status on and off in this web page. That's why. So look at this update web page creates a dynamic web page. So we create here a string variable ptr, and then we have to specify the declaration, okay, what type of string that we want to send, and we want to send an HTML document. So we have to specify that we are sending the HTML to generate the web page, right? So on a web browser. So then we have to specify the viewport. Look at this is a viewport. Basically it allow us to resize, make the web page that we are hosting on to the web server on NodeMCU will be responsive, so it will resize in all size of devices and screen. And this web page has a title LED control. So if I can make it small, you can see the title is LED control. Look at this, on a browser, on a tab, it says LED control, right? And then there are a lot of code here. This is an HTML style sheet, like which font we want to use onto the client, onto the web page, and how it should look, and all of the things. Then the body of the web page color, and then we have to specify like the heading 1, heading 3, and its specification, style sheet, which color, what size of the font it is, and all other things. Then we have the buttons, right? Look at this, we have this button, on and off button, and we also have to create a button. That's why we say the button class here. And then we have to specify what is the size of button and how the button should look like, and the font and other colors and other things. And then we have to specify the button on, like how the button color will look like. So look at this, so by default it's a blue color, and when I press the button, okay, the color changes. So active and inactive, right? So active is when you press the button, then what to happen. Inactive is when we don't press the button, right? So there's nothing like inactive, but just trying to put things in perspective, because the button on basically when you don't do anything, when you don't click the button, and button off basically is, especially look at this, button on active, so when you hit the button, and when the button off active, when you press the off button, then it changes its color. So these are basically the color codes, right? So you can play around these things. This is HTML. I don't want to go very deep in it because it's not an HTML lesson or video, by the way. And then there's a font size. You can just change all those things and just change and upload the code onto NodeMCU and play around this, and you're gonna learn this. And then closing the style sheet, closing the head and heading and body and other things. And then there is the header 1 ESP8266 web server. So this one, if you want to change it, then using a station mode. So this is like header 3. You can see h3 tag, h1 tag. I have used HTML, and then this is basically to generate the dynamic this label, right? So it's basically dynamically generate. If somebody press the button, then this dynamically generates basically LED off status, LED on status routes, and that's why when we press the button, then it's basically dynamically generates this based on whether the NodeMCU LED on a NodeMCU is on and off. And that's pretty much the code is all about. I would suggest like play around this code, modify a little bit here and there, and then see how it works, right? So let me show you how it works in the real life. So let me close this tab here and just keep it fresh for you to show. Now before we upload the code, I think you know that we have to make sure the board properly selected. It's a NodeMCU 1.0 ESP8266 module, and then make sure the COM port is properly selected, COM3 in my case. Let me upload the code. When this code will get uploaded on my NodeMCU, then my NodeMCU will try to connect to this network, this binary update network, and it will get the IP address. Okay, that IP address is assigned by my internet router, and that IP address is basically the IP address of a NodeMCU ESP8266, which is not anymore just a microcontroller, but it's a web server. So we will use that IP address and put it into the browser here, right? So just wait till this code get uploaded. So it's still uploading. So it takes some time. So you see in a lower left corner it says done uploading, and now I'm going to tools and open a serial monitor and make sure the baud rate is 9600 because that's what we wrote in our Arduino code. And then we have to wait if something happens here. Okay, if nothing happens, then we have to press the reset button on NodeMCU. And when you press the reset button, then you see it says connecting to binary updates. That's what I said. My NodeMCU will try to connect to my internet router. Once it connects to internet router, then the NodeMCU will get the local IP address, and that's the IP address of our web server. So I can copy this IP address 192.168.225.23, and then I'm going to paste this IP address here in the browser, and when I hit enter, look at this, what happens. It will call the root and then it will present us the web page that we wrote the code. And as I said, by default the LED status will be off. That's why it reflects LED to be off. Okay, now when I press this button on, then it will dynamically change this URL, because the concept of a web server is basically the client sent the particular URL as a request to the server, so that the server will then serve that request and give us a response back, and then this label will also get changed dynamically. Look at this, what happens. So let me press the button on. So when I press the button on, then the request is served from the client, means our web page, to our NodeMCU. That's why we receive the LED on, because from the browser we have sent a request that the IP address /LED on. This is the routes that get called to the web server, and that's basically ultimately turn on the LED onto the NodeMCU. Now when I press this off button, you see it dynamically changed this label as well as this URL, and it will send us here LED off. Look at this. Let me press the off button. So when I press the off button, you see it dynamically changed the URL, so it sends the request to be IP address /LED off, and it changed the label to be off, and we have here off, and LED turns it off. So you can press this button on and off randomly, and you see the LED gets turns on and off because this URL will get sent as in the form of request to the web server, which is running on NodeMCU ESP8266, and when we receive the response back 200 OK, and it dynamically generates the web page. That's basically how you can even try and control the LED by mobile phone, but just keep in mind that your mobile phone will also get connected to the same network, so it also has to connect to the binary updates network, and then you can open the Google Chrome on your phone and put this IP address, and then you will get to see the exactly same web page will shows up there, and then you can press the button and you can control. So multiple client basically can able to control the NodeMCU in the local network. That's basically what the web server is all about into the station mode. Now, as I said, there are different ways NodeMCU and ESP8266 can be connected to the internet and the Wi-Fi. It will connect in the station mode, then the access point mode, where the NodeMCU itself will be an internet access point. So in this case, we need to connect to this internet access point binary updates, but in that access point mode, soft access point mode, your NodeMCU doesn't need any internet from any other external source, so it itself will be acting as an internet router, and it will connect to different devices like a mobile and different laptops in the same network, and can able to control the LED connected to NodeMCU. So that is the next video. You can check out the link in a video description, and I will be posting that next video, how to configure the NodeMCU and ESP8266 into the access point mode. So you will learn both these concepts, and so you can better use the concept of web servers into your products and projects that you are working on around the NodeMCU. I hope you have found this video educational and entertaining. We create an awesome courses at binaryupdates.com. I wanted to keep this video short and simple, to the point, to explain what the concept of web server is all about. That's why I didn't type the code line by line. It is too big and too many things to explain and doesn't make sense. If you're looking for line by line typing of the code and explaining everything, much better graphics and animation, then check out our courses, online courses. We have given a link in a video description. You can check out our courses that would help you to become an expert in the embedded systems and Internet of Things. Thank you very much for your time, and we'll see us into the next video. Bye bye for now.